right, this is probability day 3. Had some questions on the homework last night. I know this gets tricky quickly. I tried to answer some questions over email, but there's some I definitely want to go over. First one that always gives people trouble is number 4 on the front. So the bag contains peaches and apples. Probability of picking a peach is 0.4. If there are 60 peaches in the bag, how many apples are in the bag? Okay, so this one's always tricky because it's just a little weirder than what you're normally seeing. If you've only got peaches and apples, maybe I should say peaches and apples only, probability of picking a peach is 0.4. So knowing that, what's the probability of picking an apple? Right, 0.6. Because if you do 1 minus 0.4, they should be complements, 0.6. So you can kind of set up a proportion. This is telling you that 60% of the total amount are apples. So if you just do number of peaches to the proportion of peaches, 60 to 0.4 equals how many apples, I don't know, to the proportion of apples, 0.6. Let's see what that gives us. So 60, from cross multiplying, times 0.6 is that number, divided by 0.4. And there it is. It's that simple. Again, just weird because it's not exactly like what we've been doing, but that's kind of the problem with probability. You'll get questions that aren't exactly like what we've been doing. All right, otherwise over on the back, a couple people asked me about number 6. Suppose that of the 400 people on a flight, 368 have checked baggages, 228 have checked baggages but do not have frequent flyer status, and 8 have neither. Using a Venn diagram or a table. Table's the way to go. It's just a little bit easier. You can see everything easier. So 400 people on a flight, that's the total. So that's going to go in the right corner of the table. We're talking about checked baggage, and we're talking about frequent flyer status. So checked baggage, not checked baggage. Frequent flyer, not frequent flyer. That's how you set up tables. Think of your two things that you're talking about, the yes and the no. Then make a table. And then when we make this table, we're also going to, don't forget to do the totals. Okay, so 400 people on a flight. That has to go in the corner here. 368 have checked baggage. So go to the checked baggage row, and that's the total. 228 have checked baggage, but do not have frequent flyer status. So yes, checked baggage, not frequent flyer. This has to be 228. And then 8 have neither frequent flyer nor checked baggage. So not checked baggage, not frequent flyer, that's 8. So that's all we got, but that's enough. If I use my calculator, I can fill in the rest of the pieces. Maybe I don't even need them. This is going to be 32 here, right? 400 minus 368. And then, let's just use it. 368 minus 228 means this up here would be 140. 32 minus 8, that's 24 here. And then we just add down. So this would be 164. This would be 236. And double check. Is that going to get us to 400? Yep. So now you can use this to answer your questions. How many have, it's not probability, it's just how many, have frequent flyer and checked baggage. Checked baggage, frequent flyer, it's right there, 140. And how many just have frequent flyer? Look at the total of the frequent flyers is 164. All right, so again, filling out the table makes answering these questions real easy. Okay, number 7. What's the other one I wanted to go over? Just part A. When an animal is selected at random from those at the zoo, probability that's North American is 0.65. Probability that's both North American and a carnivore is 0.16. And the probability that's neither is 0.17. Filling out the table looked fine. It was the Venn diagram that messed some people up. Because I do think Venn diagrams are harder to make. So if you have a choice, go with the table. All right, if possible, fill in the middle first. And that is, we have this. It's both North American and a carnivore is 0.16. So that's going right here. I saw some people, well, we should label these. North American and carnivore are the two things we're talking about. So you should only have two circles. You don't need yes North American, no North American, because no just means it's outside the circle. So North American is 0.65. Remember, don't put 0.65 here. This whole circle has to be 0.65. So you've really got to do 0.65 minus the 0.16 that's already been accounted for, which is 0.49. That's what goes here. And then neither is 0.17, so that's out here. How do I get what goes here then? Well, all the probability, this is the only space left, should add to 1. So if I just do 1 minus 0.49 minus 0.16 minus 0.17, I get what I'm left with, 0.18. Okay, and you can use that to answer questions. But again, I think most of you would probably use the table anyways. All right, so that's what I wanted to go over on the homework. Hopefully that made sense and cleared up any questions. Here's today's warm-up. My car is brought to a repair shop. Oh, I should say shop. For service, the probability that we'll need the transmission fluid replaced is 0.38. Probability that it will need brake pads replaced is 0.28. And the probability that it will need both the transmission fluid and the brake pads replaced is 0.16. Let the event that a car needs the transmission fluid replaced be T. The event that a car needs the brake pads replaced be B. Create a table and a Venn diagram to represent this situation and determine the probabilities that follow. Wow, really bad with the spelling on this one. Okay, so I'm going to set up your Venn diagrams and your tables, and then you can pause this video and work on it. So we've got two events. Needs transmission fluid, needs brake pads. So if I make a table, it's going to be transmission, not transmission. Brake pads, not brake pads. That's how you make your table. Don't forget your totals. Okay, so why don't you pause the video and try filling those out and then answering the probabilities. Okay, ready to see it? Here we go. We'll do the Venn diagram first. Probability that needs transmission fluid replaced is 0.38. I hope you didn't put 0.38 there. Brake pads is 0.28. Similarly, this is not 0.28 because both is 0.16. That goes in the center. So now you can use that to figure out what's left over. Transmission fluid was 0.38. So if I do 0.38 minus the 0.16 that I've already taken into account, this needs to be just 0.22. And similarly, brake pads is 0.28. Take that 0.28 minus the 0.16. It's 0.12 right here. And to get what goes on the outside, we subtract everything from 1. So 1 minus 0.22 minus 0.16 minus 0.12. So we're left with 0.5 outside. Okay, so that's the Venn diagram. Let's do the same thing with the table. Again, the nice thing with the table is you can put everything in there right away. Needs transmission fluid is 0.38. So go to transmission fluid, that's a total. Needs brake pads is 0.28. Go to brake pads, that's a total. Needs both is 0.16. So transmission and brake pads is 0.16. Now the other thing I can fill out right from the get-go is this spot. What should this spot down here always be if it's a probability chart? 1. So now I can fill in the missing pieces. So you'll see I'm going to do a lot of the same calculations. I still need to do 0.38 minus 0.16 to get what goes here. It's 0.22. And I still need to do 0.28 minus 0.16 to get that 0.12 number. It's got to go right here. Now if I do 1 minus 0.28, we get 0.72 for here. If I do 1 minus 0.38, I get 0.62 for here. And finally, 0.62 minus 0.12 or 0.72 minus 0.22. Either way, I get 0.50. Okay, now let's see if I can answer the questions. If I wanted to do probability of t, I'd have to add this whole circle. 0.22 plus 0.16 is 0.38. Or I can look at the total of this column. Either way, 0.38. Same with probability of b. I would need to add these two together, which would be 0.28, or look at the total of the b column. What's this symbol mean? This means and, intersection. I almost think of it like I'm about to write an A, but I never wrote it. So remember that means and. So that's the middle. That's easy to see in the Venn diagram, but it's also easy to see here, T and B. And then what's this mean? Well, this means T or B, and that means not. So this means not T or B. So that would be what's outside the circles, 0.5, or not T, not B. Either way, it's 0.50. All right, so again, generally I'm not going to make you do both of those, but you should be comfortable doing them in case they specify. But if you have a choice, I go table every time. All right, we're up to probability day 3. This is called the addition rule. And if you notice, example 1 is the exact same as the warm-up. Still talking about that car into a repair shop, needs transmission fluid is 0.38, brake pads is 0.28, needs both is 0.16. But this time I want to find the probability that a randomly selected car needs transmission fluid or brake pads replaced. Okay, so I'm just going to kind of speed things up here a little bit. I'm going to make the table. And this is going to be exactly the same as the table that, oops, I didn't mean to do that. Exactly the same as the table that I made right here. So we'll do transmission, not transmission, brake, not brake, and then totals. And I'm not going to spend time going through all the calculations because, again, this is exactly what we just did in the warm-up. I'm just going to fill them in for you. This is 0.16. This is 0.22. This is 0.38. This is 0.12. This is 0.50. This is 0.62. And then finally, this is 0.28. This is 0.72. This is 1.00. Okay, so just from the information that was given to us, we know the probability of transmission fluid replaced is 0.38. We know the probability of brake pads replaced is 0.28. We know the probability of both transmission fluid and brake pads is 0.16. The event that a car needs the transmission fluid replaced, BT. Okay, find the probability we need transmission fluid or brake pads. So we want probability of T or B. Again, union means or. Okay, so I want anything in the T column. So that would be any of this stuff. Or I want anything in the B column. That would be any of this stuff. So I can just add up all the numbers in this row and this column. So this is going to end up being 0.16 plus 0.12 plus 0.22. Now notice I didn't count the totals. So maybe I should have circled it like this. I want anything that needs transmission, which is everything there, and I want everything that needs break, which is anything there. So I have to take these three red numbers into account, 0.16, 0.12, 0.22. And if you add those up, 0.16 plus 0.12 plus 0.22, we get 50%, 0.5. Oh, what just happened? Sorry. Now, as a side note, could we also do probability of transmission plus probability of break equals probability of transmission or break? Because that's what a lot of people think. I'm going to put a question mark there. If I want either or, could I just add those two totals together? Well, let's see. If I do that, I get the total of transmission was 0.28. Total of brake pads was 0.38. And what's 0.28 plus 0.38? 0.66. But we know the answer is supposed to be 0.5. So no, that doesn't work. Why? If you look at this table, what's the problem with me just taking this total plus this total? Well, it kind of shows you in the table. If I just take this column and then I add this column, I just double counted this 0.16 right here. That's part of both columns. That's part of the 0.28 and it's part of the 0.38. So the reason why, because we're counting the points, what was that? 0.16 twice. So that's why just adding the totals doesn't work, because that both, the overlap, is included in both totals. So what we would need to do is we would need to say the probability of T or B is the probability of T plus the probability of B. But then, again, think about what we did. I know this is getting kind of messy over here. But if I take that 0.28, I get those two numbers. If I add the 0.38, I get those two numbers. I want to count this 0.16 one time, but I don't want to count it twice. So this counts it twice, so just subtract off the probability of the overlap. And again, we have to subtract off the overlap because we counted it twice. The probability of T was 0.28, plus probability of B was 0.38, but then subtract off that overlap of 0.16, and then see what you'll get. 0.28 plus 0.38 minus 0.16. What just happened? Go to. Oh, I forgot a plus. Oh, no. Okay, let's do it again. 0.28 plus 0.38 minus 0.16, 0.5. And that is what we're supposed to get. Okay, so that last rule I just did is called the addition rule of probability. If you want to find an OR, probability of A or B, you can add them, probability of A plus probability of B, but make sure you subtract off the overlap, probability of A and B. So subtract off overlap, because we don't want to count it twice. All right, let's do some examples. Small high school surveyed 52 of its seniors about their plans after they graduate. They found the following data and wanted to analyze it based on gender. In this case, if we pick a student at random, we can place them into one of 4 events. Now, there's something missing about this table. What's missing? Right, the totals. And you'll see that a lot. So if there's not totals, get them first. So 16 plus 14 is 30. 13 plus 9 is 22. 16 plus 13 is 29. 14 and 9 is 23. And when you add down either column, you should get a total of 52. Okay, keep that in mind. What is the probability that a person picked at random would be a female who is going to college? Represent this using either a union or an intersection. So we want a female going to college. Is that a union or an intersection? That's kind of an and. So we're looking for probability of female and college. So I would just look at my table. That's 13. Remember, it's probability. So you've got to say 13 out of the total, 52. And 13 out of 52 is the same as 1/4. What's the probability that a person picked at random would be a female or someone going to college? Or, remember, is a union. So probability of female or college. So I want anyone in the female. So I want these two. And I want anyone going to college. So I want these two. So I could just do 16 plus 13 plus 9, all those out of 52. And what's that come out to be? 16 plus 13, plus 9. I'm going to get 38 out of 52, which reduces to 1926. So 38 out of 52, which is 19 out of 26. Okay. Part C, explain why probability of F or C does not equal probability of F plus probability of C. Well, we just got that this was 19 out of 26, and that supposedly would not equal the probability of being a female, which would be 22 out of 52, plus the probability of going to college, which would be 29 out of 52. And if you try this, 22 plus 29 is 51 out of 52. And those obviously aren't equal. Why are they not equal? For the same reason they weren't equal a second ago. If I just take this total plus this total, I'm counting that overlap twice. So the reason is because we're counting the probability of F and C twice. Because if I just take the totals, that 13 is in both of those totals. It's part of the 29 and it's part of the 26. So the general probability rule, based on, I guess I'm talking about part C here, would be the probability of F or C is equal to the probability of F plus the probability of C minus the overlap, probability of F and C. And that formula would have worked because we would have had 22 out of 52 plus 29 out of 52. But then I would have subtracted off that overlap, the 1/4 or 13 out of 52 that I found in part A. And then if I do that, I'd have 22 plus 29 minus 13, which is 38 out of 52. Which reduces to our 19 out of 26 again. Okay, so this is just to show you the formula works. If you remember to subtract the overlap, and just looking at the table and counting the numbers you need once works. Same answer. Sometimes we can avoid that law that we just did in this last part here, in part D. Wow, so many mistakes. By simply keeping careful track of what elements are in the sample space and making sure we don't count any element twice. That's what I just meant by using the table. making sure we don't overcount that 13. Now this brings about something that you've maybe heard of before. There's this notion called mutually exclusive. That's when there are no outcomes in common. Okay, so mutually exclusive, if I made a Venn diagram of something that was mutually exclusive, that means if I have A and B in my Venn diagram, this would be 0. So there's nothing in common. There's nothing in the middle. So probability of A and B would be 0. Just think of it as no overlap. So you might have remembered in the past sometimes when you do just add one probability to the other. And don't worry about subtracting off the overlap. In younger grades, sometimes we do that because we don't have to worry about this. Those examples all are mutually exclusive. Because if I subtract off the overlap and I'm subtracting off 0, then I could just add the two together. So if they're mutually exclusive, if you want the OR probability, then you can just add the two together. Okay, let's do an example where they're mutually exclusive. On a certain midterm exam, there were 7 A's, 12 B's, 3 C's, and 1 F. Determine each of the following probabilities. Well, first, how much total have we got? Because if I'm doing probabilities, I need to know a total. 7 plus 12 is 19. 19 plus 3 is 22. Plus 1 is 23. So we have 23 total. Okay. Probability that they get an F, what's that going to be? 1 out of 23. Just remember to make it a probability. Number of F's out of the total. Probability of A and B. So probability that one person chosen at random is an A and a B at the same time. That might be a little misleading, but it's actually 0 out of 23. Or 0. Some of you might have been thinking, well, I add 7 and 12 and get 19. No, that'd be A or B. This means the probability that a single person chosen at random got an A and a B. A single person only got 1 grade, so they can't get both an A and a B. So can't get A and B at the same time. That one test grade is going to be one or the other. So if I want probability of A or B, then I could just take the 7 out of 23 plus the 12 over 23. And why don't I have to subtract off the overlap? Why can I do that? Right, because there is no overlap. It's mutually exclusive. So that's 19 out of 23. Probability that it's a B or not A. Okay, well, a B is 12 out of 23. Now, not A does have an overlap with B because B is part of not A. So keep track of what you're doing. So not A means B, C, D, or F. But I don't need to count the B again because I already did that. It's kind of redundant. So the C's, there's 3 of them. There were no D's listed, so I don't have to worry about that at all. But there is 1 F. So 12, 15, that's 16 out of 23. Are A and B mutually exclusive? Why or why not? We already talked about that. Yes, they're mutually exclusive because there's no overlap. No one student got an A and a B at the same time. Okay, so that one I didn't even really draw a picture, a table, or anything. I just was able to keep track. And it's easier to keep track if they're mutually exclusive. All right, number 4. Insurance companies typically try to sell many different policies to the same customer. At Flo's insurance company, 56% of all customers have car insurance, 48% have home insurance, and 18% have both. A customer is picked at random. We want the probability that he or she has at least one of the policies, and the probability that she has neither of the policies. Now, I could make a table, but what I would suggest you start doing from here, a table is nice, but it's a little clunky. It takes a little bit to do. I would start by listing out what you do have, what probabilities you know. 56% have car insurance, so probability of car insurance is 0.56. 48% have home insurance, so probability of home insurance is 0.48. 18% have both. So don't write this. Don't write probability of both. That messes people up. Write it in terms of the events that you have. Both means car and home. So that's 0.18. So for part A, we want the probability that he or she has at least one of those policies. Now that's worded a little bit. At least one means they have car or home. At least one. So they might have both also. So this is the OR. And this is the formula we did today. What's the formula for OR? It'd be probability of car plus probability of home minus the overlap, probability of car and home. And this is why I have you list this stuff out. We've got all the information to plug right into the formula. It's 0.56 plus 0.48 minus 0.18. .56 plus 0.48 minus 0.18. And you get 0.86. So if you know the formula, it's easier to just use that and apply what you know. Okay, part B. Find the probability that he or she has neither of these policies. So that's not car and not home. Or we could think of it as not what I just found. So this is having at least one. So the complement of that is having none of them. What's the easiest way to find a complement? Remember that 1 minus trick. 1 minus 0.86. So that answer is going to be 0.14. Because either they have at least one or they don't have either. There's no other option. Okay. 5 is multiple choice. Given that probability of A is 0.3, probability of B is 0.7, if A and B are mutually exclusive, what's that mean? No overlap. Which also means that the probability of A and B is what? 0. Okay. Which of the following is a true statement? Well, right now I see 2 probabilities of A and B, and neither of them are 0. So 2 and 3 are out. Both 1 and 2 can't be true because 2's out. So we're down to 1 and 4, which are the OR questions. So if I want to find the probability of A or B, the formula we've been using all day is probability of A plus probability of B minus probability of A and B. Remember, in this case, probability of A, which is 0.3, plus B, which is 0.7, we said the and was just 0. So I don't really need to worry about that overlap. So this is 1.0. It's choice 1. So if they're mutually exclusive, then you're allowed to just add the 2 probabilities together because there is no overlap. Okay, last page. There are 20 climbing ropes at Merritt Climbing Walls. 5 are thicker than 8 millimeters, 4 are waterproof, and 1 is both. What is the probability of being thicker than 8 millimeters or waterproof? Again, before you jump to the table, list out the probabilities you know. Probability that thicker is, there's 5 out of the 20. I'm just going to reduce at the end. Probability that they're waterproof, that's 4 out of the 20. And probability that they're both, don't write both, write thicker and waterproof, is 1 out of the 20. What are we looking for? Probably the rope being thicker or waterproof. Okay, so get used to formulas. Probability of thicker or waterproof would be equal to probability of thicker plus probability of waterproof minus the probability of thicker and waterproof. Do we have all that information? Yes, we do. So we don't need a table, we can just plug it right in. 5 out of 20 plus 4 out of 20 minus 1 out of 20. So that's 5 plus 4 is 9, minus 1 is 8 out of 20. Reduce that, it's going to end up being, take 4 out of each, 2/5. Okay, now could you make a table? Again, yes. If you get on a test or something, or the Regents, and you realize, have no idea what the formula is, make a table, and you can maybe figure this out. But if you know the formulas, that's what I'm going to focus on. All right, last one. The probability that Maggie has ice cream in a waffle cone is 0.4. So I'm going to start right away. Probability of waffle is 0.4. Probability that she has it in a sugar cone is 0.5. Probability of sugar is 0.5. What is the probability that her ice cream is in a waffle cone or a sugar cone? Okay, well, we know the formula would be probability of waffle or sugar, which is probability of waffle plus probability of sugar minus the probability of waffle and sugar. So it seems like I don't have enough information. But what else is implied here? Okay, well, picture holding an ice cream cone. Could that cone be a waffle cone and a sugar cone? No, those are two different types of cones. Can't be both. So what's that mean? Yeah, it means this is 0. These are mutually exclusive. So the answer to this is just going to be 0.4 plus 0.5 because that overlap is 0. So just 0.9. So you do have to be a little smart sometimes and think about, do you know for sure there's no overlap? This is a situation that you should know for sure is no overlap. All right, that's the end of it. Good luck with the homework tonight. As always, email me with questions.